Okay, welcome back. I am excited about these problems. I think these problems are so much fun. We get to use the quadratic formula to actually solve some stuff in real world life, all right? These problems are all about throwing things or jumping off things or launching rockets and how it really works in real life. And I'm all about doing those things, so these are fun for me. So let's get going. Now, at this point, we are pretty much experts at using the quadratic formula. And if you're not quite sure, make sure you go back and watch the previous video because we're going to use it here and we're going to be using it pretty quick. So let's look at this problem. Jason decided to go cliff jumping in Tennessee. I've done that. It's awesome. His function as a height of time could be modeled by the function h of t equals negative 16t squared plus 8t plus 40, where t is the time in seconds and h is his height in feet. Letter A, when did Jason reach his maximum height? Okay, now, here's a huge thing for solving these problems. Anytime it talks about maximum height, let me draw a picture here. See if we can figure this out. Okay, now, if you're a physics guy, I know I'm making a small mistake in this picture that's really going to make it a whole lot easier for me if I teach it this way in this lesson. Okay, so I know I can hear you saying it right now. All right, but if you're one of my Algebra 1 students, you really don't care. You're just like, make this easy, right? So I'm going to make this easy. So Jason's standing on the top of the cliff. He jumps up a little bit and he comes down and he lands in the water down here. Okay, what I want to know for letter A is this point right here. When did Jason reach his maximum height? Well, if I just continue this down this way, which doesn't really exist, I'm just drawing this. You see what we've got here? We've got an upside down parabola, all right? And the middle of that parabola, right there at the top of that, that is called the vertex, right? And we know how to find the vertex. Let's see if I can get some of this erased. We know how to find the vertex of something. We just have to go negative b over 2a. So first thing, let's go ahead and do, let's get a, b, and c. A is the number in front of x squared, b is the number in front of x, and c is the number by itself. Okay, so the vertex for letter A, we need to go negative b over 2a. That's how we find the vertex. So negative b is negative 8 over 2 times negative 16. And so let's see. This is going to be 8 over negative 32. I'm sorry, negative 8 over negative 32, which is going to be positive 1/4, or right now we'll use a decimal, 0.25. Okay, and this is time in seconds. So Jason reaches his maximum height at 0.25 seconds. That's the vertex. Letter B. What is the highest height? Well, all that means is at the vertex, how high is he? So we know the time is 0.25. What we're going to do, we're going to take 0.25 and sub it back in for t up here in this equation, and that's going to give us our height. So I'm just going to use my calculator. Negative 16 times 0.25 squared plus 8 times 0.25 plus 40, what's that going to be? 41. So the highest he's ever going to get is 41 feet, and that happens at 0.25 seconds. That's our vertex. 0.25 seconds, 41 feet. That's our vertex, okay? So that the answer for letter B, how high does he get, is 41 feet. Let's look at letter C. When was Jason 10 feet above the water? Okay, so this 10, that's a height. So let's come back and look at this equation that we had. We had negative 16t squared plus 8t plus 40, and that was equal to the height of 10. Okay, now how do we solve this? Well, we'd use the quadratic formula, but remember, quadratic formula has to be equal to 0, right? So let's just take the 10 and subtract it over so that this will be equal to 0. And 40 minus 10, that's going to be 30. Okay, so now let's find our new a, b, and c here. A is the number in front of t squared, b is the number in front of t, and c is the number by itself. Now let's use the quadratic formula. Negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Okay, now this is a lot, so I'm just going to punch this into my calculator real quick, and let's see what we get. Negative 8, first we'll go plus b squared minus 4 times negative 16 times 30 all over 2 times negative 16. So the first answer is negative 1.14, and I'm going to have to erase this up here so we have room to write it. So the first answer is negative 1.14 seconds, and the second answer is going to be 1.64. 1.64 seconds, okay? That's when he's 10 feet above the water. Now, let me ask you about this. Do both of those answers make sense? Was he 10 feet above the water at negative 1.14 seconds? Well, unless it's a special situation, negative times really don't make much sense. We're only going to use positive times, so that's going to be positive 1.64 seconds, all right? Let's do the next one, letter D. When did Jason hit the water? Now, this one's tricky. This one is so hard to see. If he hits the water, what does that mean? That means his height is actually 0. All right, that's when he hits the water. If he hits the water, comes down, his height is 0. So if I put 0 in for H, now my A, B, and C that we found earlier are still actually what we need. So let's use the quadratic formula here to solve this. Negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. All right, now I'd encourage you to maybe pause this video and work this out yourself, but I'm going to go through and work this pretty quickly. Whoops. Actually, it's going to take me a second. I just deleted everything. Negative 8 plus the square root of 8 squared minus 4 times negative 16 times 40 all over negative 16 times 2. Okay, so my first answer is going to be negative 1.35. And my second answer is going to be 1.85. So I'm going to erase this so that I can actually write it in there. 1.85. Now, again, we don't want a negative time in this. So Jason hit the water 1.85 seconds after he jumped. Okay? Kind of cool, I think. Let's do another one. This time we're launching a rocket, and I like rockets. I think this is going to be fun. A rocket is launched into the air. The height as a function of time could be modeled by the function h of t equals negative 16t squared plus 96t, where t is the time in seconds and h is the height in feet. When does the rocket reach its maximum height? Well, again, when does it reach maximum height? If it's talking about maximum or minimum height, highest or lowest, that's the vertex. So let's start by writing A, B, and C. A is the number in front of t squared. B is the number in front of t. And C is the number by itself, so that's going to be a 0. So to find the vertex, we need to go negative b over 2a. Negative 96 over 2 times negative 16. That's going to be negative 96 over negative 32. Negative 36 over negative 32, which is going to be a positive 3. Okay, so we know at 3 seconds, that rocket is going to have reached its maximum height. Okay, now that's the x value of the vertex. Letter B, what is the highest height that the rocket reached? That means we need to put that 3 back in for the t up here. 3 is a time. What's the height? So negative 16 times 3 squared plus 96 times 3 equals 144. So the highest height that this rocket reaches is 144. Now, we've been doing this forever, right? 144 is the vertex, negative b over 2a, and then you put that in, and that's what you get. So at 3 seconds is its highest point, and that highest point is 144. Let's look at letter C. When does the rocket hit the ground? Well, we know that when it hits the ground, that means the height is 0. So let's come back up and look at our equation right there and solve that using the quadratic formula. So we've got negative b plus or minus the square root of b squared minus 4 times a, times 0, I lost that in there, times c, all over 2a. Okay, so when we look at this, again, you can use your calculator. That'll get it all done if you want. But when we're all done with this, this is just going to be 96 right there. And 2 times negative 16 is going to be negative 32. So let's look at this. Negative 96 plus 96 is 0. Divided by negative 32 is going to be 0. And then if we put minus negative 96 minus 196 divided by negative 32, that's actually going to give us 6. So we've got 2 answers there, and neither one is negative, so they both look like they might work. But let's look at the question again. When does a rocket hit the ground? So think about how this is working. The rocket is launched. It goes up, and then it starts to come back down, and then it hits the ground. So at 0 seconds, it was on the ground because we launched it from the ground. But that's not really when it returns or hits the ground. So we're just going to go with 6 seconds. Okay, letter D. Now this is going to be a challenging problem. How long was the rocket higher than 100 feet? So let's see. Here's what we've got. We've got the ground there. The rocket goes up, comes back down. And we know that the highest it gets is 144 feet. But that means somewhere in here, there's going to be like a 100-foot mark. And I want to know how long is that rocket above it. So here's what I want to figure out. I want to figure out when does the rocket hit 100 feet for the first time, then it's going to come back up, be higher than 100 feet, up to 144. Then I want to know when it comes back down and hits that. Okay, so here's what we got to do. We got to go back up to our original equation and put our height. I don't want the height of 0 this time. I want the height as 100. Okay, 100, because that's what we're looking for, 100 feet. So this has to be 0. We have to turn it to 0, so we need to subtract that across. Because remember, when we use a quadratic formula, it always has to be equal to 0. Okay? So now our C is going to be negative 100. Looking at that, A is still 16, B is still 96, but C is negative 100. So let's do this. Negative B plus or minus the square root, plus or minus the square root of B squared minus 4 times A times C all over 2 times A. Now this time I am definitely using my calculator for this. There's a lot of things going on here. So let's go negative 96 plus the square root of 96 squared minus 4 times negative 16 times negative 100 all over 2 times negative 16. First answer is 1.34. Okay, let's look at the other one. What happens if I go minus? That answer is going to be 4.65. Okay, so that means that after 1.34 seconds, it hits 100 feet going up, and then it's still up there, goes all the way up to the top, and then starts coming back down, and at 4.65 seconds, it crosses that 100-foot mark again. I want to know how long was it up there. So if it started at 1.34 and then stopped at 4.65, let's just subtract those. 4.65 minus 1.34 is going to be approximately 3.01 seconds. Okay, that was not easy. Let's go back and look at these again. So, letter A, when does it reach its maximum height? If we're talking about maximum height or minimum height, that's going to be the vertex. So negative b over 2a. And that gave us the answer of 3. What was the maximum height? Well, once again, that's talking about the vertex. We know it happened at 3 seconds. We already figured that out, so put 3 back into that equation for t. And when you do that, you'll get 144. Next question, when does it hit the ground? That means the height is 0. So we're going to have to solve this using the quadratic formula. And one answer was 0, one answer was 6, but we just want to know when it comes back down and hits the ground. So that answer is just going to be 6. And then the last question, how long is it above 100 feet? So we put 100 in for the height. And remember, it has to be equal to 0, so we have to subtract that 100 over. Then use the quadratic formula, and we'll take those two numbers and subtract them. And that'll show us how long it was above. Wow, that was pretty serious. That was some good math right there. Now, I know this was super confusing. You may have to watch it again. And I know this was a long video, so watching it twice is going to be extra long, but it's going to be worth it if it helps you out and you can get through these problems. All right? Good luck.